Hello everyone, welcome to the review of the Nvidia RTX A5500. This is a really high-end professional graphics card, and I mean professional because you all know this discrepancy that we now have in the tech world about what's a professional. But this is a really nice graphic card, a really high-end graphic card. Is also quite expensive. It's not at all compared with the gaming graphics card affordable, and I think it's also a complicated topic to talk always about the price of these professional graphics cards, but I'm very excited. I have this here. I've been using it for a few weeks already in my personal computer, and I just want to show you how it performs, and most important to talk about how you really can justify the use of this and what is actually the benefit of this high-end or ultra high-end professional graphics cards that are totally overrated, and they are very expensive in comparison to the gaming counterparts. And I think that is actually the most important thing of today. Talk about what really benefits can they offer you, and of course we are not going to leave behind some of the examples that I personally use for my studies, for my research, and how it can really benefit real life workflows and what is the advantage that you can really get out of it. We're going to talk about 3D modeling. We're going to talk about a little bit of mechanical engineering software, like for example Solidworks. We're going to talk about a little bit about 3D modeling in Catia, but we are going to jump also in as well in how this kind of graphics card can really help you, for example, in order to accelerate your finite element simulations. That is a really important thing for me at least, and for a lot of mechanical engineers. And that is actually one of the biggest benefits that you could get out of a graphics card like this. Thank you very much guys for coming back to my YouTube channel. I was absent a little bit a while, but of course, like always things to do, and I really do my best in order to keep posting some videos for you just because I like. So let's start as always with this graphics card review with the design. Now after that we're going to talk about a little bit about what is the purpose of this graphics card, but first just take a look to the design. This is a dual slot graphics card. This is not anymore a single slot graphics card. As you can see here, it's a little bit thick, but it's really perfect dual slot. It is not something like with a heavy cooler or something like that. It is a dual slot machine, which it means that if you have this standard distance between PCI Express to PCI Express, this will allow perfectly to install a secondary graphics adapter in the PCI Express below, which is a really nice thing because these quadros are made for workstations on multi-purpose, multi-GPU workstations, for example. So this is a dual slot. It's actually just black. It's just black, but it has really nice gold accents, like gold accents here in the actually cooler, in the metal of the cooler. We have gold accents, for example, in the small letters of Nvidia RTX A5500 and in the Nvidia logo, of course. But besides that, it's really just pure black. It's a matte black, really nice. It is not glossy, it's actually like matte black, and that's pretty much of it. I mean, I like it a lot because it's very minimalistic. It shows nothing, and I like a lot this kind of designs. This graphics card still has the NVLink. NVLink is still available for professional graphics cards for GPU computing, which is a pretty cool thing. You can link, I think, up to 4 of these, and it's an amazing thing. One of the benefits of NVLink is, for example, that if you are using like deep learning workflows where you have very heavy finite element simulations that can take advantage of the memory and of the together computation of the graphics cards, you can join them with NVLink, and the computer or the host computer, the host machine, is going to identify as the multi-GPU configuration as a single GPU, which is going to allow your software or your application to take full advantage of the multi-GPU configuration that you have as a single GPU, which is an unbelievable thing. And in the next part, we have this stereo audio configuration. I hope you can see here a little bit. This is very old already for Nvidia Quadros, maybe like already like 10 years or something like that, but it's still present here, and I think it's a really nice thing. In the last connection that we have here, this is a sync connection. I really do not know exactly what is the purpose of this sync connection, and I found a little bit of information on the internet, maybe something similar like the MB link. Yeah, I think it's also as well kind of like to synchronize the graphics cards if you are displaying the output of all of the graphics card that you are using in your multi-GPU configuration, and I think it's more or less the purpose of that one, but I'm not really sure. But yeah, those are the three connections that you have here. You have only 4 display ports, 1.4A. They allow the output up to 8K 60 frames per second and 4K up to 120 Hz per second, 10-bit color, HDR, and everything is capable of this. We don't have HDMI 2.1. I think that's a shame, but it is not supposed, or it was not meant like to get connected to like TVs or something. But for your information, I have this graphics card connected to my 4K OLED 120 Hz HDR LG C242 inches TV, and it works perfect. All the features of my TV are working perfect, as you can see here, and even the G-Sync compatibility is working without problems with this graphics card. So this is a little bit of the history of the design of the graphics card. As I just mentioned, pretty simple. They just wanted to keep it simple, dual slot graphics card, gold accents, all the connection that you can expect from a Quadro graphics card, 4 display ports, and of course we are forgetting one thing. We are forgetting the 8-pin power adapter. This graphics card can demand up to 230 watts. That's why you only require one 8-pin, which is pretty cool, of course, in the side of power efficiency. So this is from the Ampere architecture. It is based on the chip GA102, again from the Ampere architecture, and it has a manufacturing process of 8 nanometers. It's actually pretty cool. I remember back on those days, it was like really a high amount of transistors, but like, I don't know, maybe like in the 1.7 billion transistor or something like that, and now we are up to 28.3 billion transistor in this GPU, and it's insane. I mean, almost 30 billion transistors in the chip that you can see here is really a nice thing to see through the years. And the launch price of this graphics card is really expensive. That is one of the main advantages of the Quadro lines, as you probably may know if you are in this video. The launching price of this graphics card was 3,000 euros, at least here in Germany, or maybe even a little bit more at the beginning. But it was like around 3,000 euros as well for you. If you are living in the United States or in another country, you can make the conversions around 3,000 euros, 3,000 US dollars, which is actually pretty expensive. It offers, that is one of the nice things as well of this, it offers an amount of 24 gigabytes of GDDR6 memory. It has the feature of can offer the ECC or the error correction code capabilities. It's also a very nice thing, and that is actually one of the nice things of this graphic card is the amount of memory. And in its gaming counterpart is actually the Nvidia RTX 3080 Ti. This is the Ti version of the Nvidia 3080, and yeah, I mean, today and the day of recording this video in April 2023, the price of the Nvidia RTX 3080, for example, in the second market or in the second-hand market, it is around 800 euros only. And this guy, you cannot even find it second-hand most of the time, but this guy second-hand is around 2,500 euros. So you can see the price difference in between these professional graphics cards and the gaming graphics cards, around 3 times price difference for the same amount of performance. Maybe like 1 or 2% less for this professional graphics card. So the price is one thing to take always into account. This graphics card has an insane amount of 10,240 CUDA cores. I mean, back in the days with the Nvidia Quadro K6000s, we used to have like, I don't know, like 2,000 CUDA cores or something, I remember, maybe less. And these guys, nowadays, they have more than 10,000 CUDA cores. I mean, you can do a lot of things only because of the amount of CUDA cores that this type of graphics card packs. It is, as I just mentioned, similar to the Nvidia RTX 3080 Ti in the gaming sector. But it has as well 80 of the second generation of Nvidia RT cores, ray tracing cores. It offers as well 320 of the third generation tensor cores for deep learning applications, which is also a pretty cool thing. If you are in that field of deep learning or machine learning, this graphics card is going to help you a lot. And it has a basic clock of 1080 MHz and it can boost up to 1665 MHz. As I just mentioned, is it a dual slot card with power demands or up to 230 watts. And now take a look now, for example, on the single precision performance. The single precision performance that offers this graphics card, it is around 34.1 teraflops. Brutal, like really great. And that's for single precision performance. In the dual precision performance side, it is not really that good. It's actually only around 1.06 gigaflops, which is it's actually not that good, to be honest. But not a lot of you guys really use applications that take advantage of the double precision single floating performance, and probably you are not going to make the difference. The single performance or the half performance computational side of these graphics cards, it helps you a lot, for example, in deep learning operation, in machine learning operations. The double precision performance capabilities, they help you in a different kind of task, like for example, for me in mechanical engineering, in order to compute or to solve this huge matrix of finite element simulations, the double precision may really benefit your workflow, but it is not that good, and this graphics card specifically was not really meant for that. But let me tell you in advance, it helps a lot in order to accelerate the computational time of mechanical simulations, just for you to know. So it is a little bit tricky, this kind of single precision performance, double precision performance, half precision performance. But I think if you are really deep into computational or numerical solutions, you really could know or inform yourself what kind of operations are you making for your application. I thought actually that it was pretty cool if I show you exactly my computer. So how do I work, a little bit of what I do, and how do I use these graphics cards? Because as I just mentioned, there are benefits, there are of course advantages, there are of course disadvantages, and I just want to show you a little bit how you may, at least as a mechanical engineer, could you benefit of this type of graphics card. Let's start by opening Solidworks. Solidworks, as you may know already, this is one of the most used 3D modeling for mechanical engineers softwares that are out there. You can use them in the United States a lot, in almost every university. Here in Germany, for example, we use it as well a lot as a part of the university licenses that we offer to students. In Spain, in whole Europe actually, Mexico, in almost every country of that, yeah, SolidWorks is very used. It's very used. So I thought we are going to start with that one. And I'm just going to open some models that I have just as an example in order to show you how the graphics card is going to work. I mean, please don't think that, yeah, that is a small model or something like that. Actually, it doesn't matter what kind of model do you open in SolidWorks. This graphic card is totally overkill. Totally overkill for almost every 3D model that you can put inside this. I mean, these models are just grabbed some from internet. They have a lot of surfaces, a lot of bodies, and for example, the real view graphics of the Nvidia Quadro are as well activated. The ambient occlusion as well, for example, I just deactivated, and it looks amazing. I hope you can see how looks this actually looks. And I will just keep opening models in order to show you that the graphics card works perfect. I will let you know here, for example, the memory that we are using of the graphics card. This graphics card, as we mentioned before, it has 24 gigabytes of GDDR6 memory, and now we are using 3.6. Now we are using almost 5 gigabytes of memory, because I am opening a big model from a Ford F150. And this video encoding that you see here is actually not from the 3D modeling software, it's because I am recording with OBS Studio and I am coding the video with the Nvidia encoder. So you can see now that I have two models open, and they are just, as I just mentioned, this graphic card is totally overkill for almost every model, 3D model that you have. Even if you have a complete car or something like that, it's not going to be a problem at all. I can keep opening models. I will just open, this is for example a real model that we construct in the university here in Germany. It is a soft manipulator, it is a soft actuator. This is actually manufacturer ready as well, not as the example that I just showed you. And it's only actually a 3 components, but actually for this kind of task of 3D modeling, doesn't matter if you are constructing, if you are making sketches, if you are making almost everything, this is going to work very, very good. Even if you have transparency effects, any effect, this is just going to make an amazing job. We can deactivate the real view graphics, we can deactivate the ambient occlusion, and I hope you can see this feature of real view graphics. I mean, I spoke a lot about this, but if you do not have an Nvidia Quadro Graphics Card, this real view graphics feature is not going to be available for you in Solidworks. This feature is already like, I don't know, 10 years ago already in the market. And it is just a very small detail, very small detail, but I love this feature personally. I really like this feature, and it makes a huge of a difference when you activate it and when you don't have it. I just activate the ambient occlusion, real view graphics, and this is how it looks. Yeah, maybe if you are making a report, if you are creating some PowerPoints or something like that, having this feature, it is pretty cool. But as I just mentioned, I just want to show you that this graphic card is going to work, and almost everything that you throw it at it is going to manage it perfect. Here, now we are using 4.6 gigabytes of memory, like really, it's like nothing. And I am here opening this as well a productive production ready chassis of as well a truck. I made this like 10 years ago when I was a design engineer. And I mean, everything works like perfect. Even if I use my 3D mouse here, it's nothing, to be honest, for such a graphics card. I lost it. It is really like nothing. But that's not all. I am going to show you as well now. I'm going to open Catia, and I'm going to open a huge model in Catia. It's going to be like a 10 gigabytes model or something like that. And I'm just going to leave everything open to show you that such a graphics card with such an amount of memory, it can help you really a lot. You know, you just to keep pushing your 3D modeling software and having no problems at all. Or at least no worries that the models are not going to fit, or that the memory is going to be saturated, or that the 3D rendering capabilities of your graphics card are not going to support your workflow. And as I just mentioned, we can just keep opening things, and yeah, the graphic card is going to make an amazing thing. For example, maybe I'm going to show you something later as well, like a more 2D. But yeah, let's wait now that Catia opens. So now the model in Catia is also open. You can see here, there are a lot of assemblies. Let me try to just show you everything. And each of these, it is like around 1 gigabyte model or something like that. It is very high quality. It comes from a computer tomography. This is the femur and tibia and femoral bones of a human body. And it is really heavy. It is really huge, high quality models. They come from a lot of meshes. And now it is a solid body. And just want to show you now, for example, now how the memory is working. Now the RTX A5500, it is using around 6.4 gigabytes of memory. And at least if you are a design engineer, if you are a construction engineer, if you are a product designer, product developer, and you are working for these insane companies that produce like Chrysler, Ford, if you work for any company in the world that really do construction in a heavy way, if you have one of these graphic cards, the only reason for you to have one of these graphics cards, like this high-end model and not the 4000 series single slot RTX graphics card, is if you are really pushing the boundaries of the memory. If you are really doing construction models that requires more than 8 gigabytes of memory RAM or 16 gigabytes, but even the RTX Ampere 4000, it offers now even 16 gigabytes of memory RAM, and over 16 gigabytes of memory RAM for just 3D modeling is going to be very difficult even to push that. So I just keep open some models in Solidworks. For example, this is a design that I made around 13 years ago or like 12 years ago. We wanted to remodel our mechatronics lab back in the days in the university in Mexico, and I just made a layout. I completely construct this from zero, so everything here is constructed by my hand. And it's a huge model. There are a lot of reflection, there are some textures, and it's really doing nothing to the graphics card. Everything is open, everything is running in the background in SolidWorks and in Catia, and everything works just perfect. I mean, yeah, the RTX 5500 is just going to make a very nice job. And if you are really pushing the boundaries of the models that you are using, this graphics card is going to, it's totally overkill still for 3D modeling, I would say, but it works perfect. I mean, it works perfect. I will not complain. I have this and it works fine. So let's close now everything, because I want to keep the memory of the graphics cards up to the minimum. Now we're going to talk about the next topic, which is going to be a little bit of accelerated computing, how you can benefit as an engineer or as a mechanical engineer in order to accelerate your finite element simulations by using Nvidia graphics cards in this case. So it's going to be the second part. As we see here now, the memory is back in the normal. I think this 1.7 gigabytes that is still using is a lot. It is using it because of the 4K 120 Hz monitor. It is using it because some of the processes from SolidWorks are still, or from these 3D models, are kept in cache for a few minutes, and because of course OBS Studio is still using a bit of memory just for the encoding and everything, but actually it's working now fine. So now I just open Abaqus. This is as well from the same house, the Dassault Systems as is SolidWorks. It is like the simulation part of the Delmia or Simulia platform that Dassault Systems offers for design engineers or for engineering fields, and it's actually pretty cool, very used in the industry. If you have knowledge of Abaqus, you can get yourself into very nice position of simulations engineer, of computational numeric mechanics engineer, something like that. It's a pretty cool software, very nice. And this is an actuator that I designed as well for the soft robotics research. You need to imagine that this is like it is a robotic actuator which is soft and which is going to bend when you apply pressure here in the internal inlets that now are closed because of the simulation purposes. But now I'm going to let pressure flow, and we are going to use this as an example. What I wanted to show you is that, for example, this kind of software have the possibility to accelerate your computational time when you use GPU, which is general purpose graphics processor units. And we're going to activate, in this case, I'm going to use only 12 cores of my computers. I have 36 threads, and Abaqus use as well the threads. But I'm just going to use 12 cores, physical cores, and I'm going to activate the use of GPU acceleration. I just want to show you how this software can really benefit out of it. We are going to submit the job, and let's wait that the graphics card is going to be used. As maybe I will keep monitoring here. The memory of the graphics card now is in 2.3 gigabytes of the 24, and we are going to wait in order to Abaqus for it to use it. It usually takes a while. The model is not that big, I remember. I think the model has, I don't know, I think it's like 300 elements or something like that. But it's really like a medium model, small finite elements model, and it has not that much elements, but because of the boundary conditions and the kind of analysis that we are doing here, it is quite computational expensive, because it is not just only make pressure and it's going to react, it is going to have a large deformation, the soft material, and it's going to be constantly changing, for example, the elements of the mesh in this case, and it is computing again and again, and in order to give you the deformation result that you're expecting out from the input of the pressure. And it's actually a quite complex topic. It is a very hot topic still nowadays, the soft robotic simulations. And what I'm doing here is trying to tell you that these kind of simulations can be accelerated using graphics cards. And in this case, having a GPU, for example, now you see that the whole 24 gigabytes of the memory of the graphics card are going to be utilized here, which means that the whole graphics card is put at use, and it is using it in order to offload the numerical calculation that this guy is doing here, which is actually a pretty nice thing. And for these cases, really the amount of memory that your GPU gives you, this kind of software, which is actually expensive. You have a lot of student licenses from the university or in order to make research. This kind of software take advantage automatically of this kind of graphics card. For Abaqus, it really makes a difference. And as you see here, for example, these bumps or these changes in the use of the 3D capabilities is when the software is really talking and communicating with the graphics card. If we can see, for example, how the CPU do that, maybe in this case it's not going to be really matching because I'm not using the full amount of CPUs, but usually it matches when the CPU is talking together with the graphics card, and then it's going to compute. And in this case, for example, if you see in the monitor of the job, it is working already. I remember it took like, I don't know, it took like maybe 30 minutes in order to initialize, to make the calculation of the assembly matrix of the whole elements. And it took really maybe like 1 hour in order to solve this model. And if it is a small model, when you use GPU acceleration, it goes really fast. And that is a really nice thing for all of you guys that are into finite elements simulations. Abaqus, in this case, is really going to take advantage of such an expensive graphic card, which is a really nice thing. If you don't forget, you have more than 10,000 CUDA cores, and this kind of software is totally using the whole amount of CUDA cores in order to parallelize the jobs, which is a nice thing. So let's kill this software. I just want to show you a small thing. For example, I'm still not finished with this new benchmark. I already have a video of benchmarking of GPU acceleration in Abaqus if you want to see it. But for example, if you have, I had one model that it was taking around 20 minutes in order to compute only with CPU cores using 12 cores, like the same that I'm using now. When I activated the GPU capabilities, it went from 20 minutes to 6 minutes, which is really insane. Just take that into consideration in order to justify if you really need a kind of graphics card like this. For this case, I will just blur the job because it is actually kind of proprietary. Yeah, it's from a student, it's for a very good friend of mine, which I was helping through the last weeks. This is it's a very nice thing. Actually, it's a very complex thing, and I really learned a lot in the last weeks about the science behind of this kind of thermal machines. That's the only thing probably that I can say. And the mesh is around, let me tell you, 1,260,000 elements. It's actually a medium to big model for a personal computer. And I just want to show you that in this kind of software as well, in Ansys, you can also use the graphics card. For example, as you can see here, I am using the same 12 cores and an Nvidia graphics card, because for this case, usually it is not really recommended to use more than 12 cores for each GPU that you have, depends. I mean, there is a lot of factors to consider, but I would also recommend personally, because of all my tests, with a maximum of 16 physical cores, not thread, physical cores, 16 per GPU that you are using. And in this case, for example, this very complex software as it Ansys officially only permits or allows the use of GPU acceleration when you have a very high-end or a high-end Nvidia Quadro Graphics Card or a Tesla accelerator. And Ansys is very, very clever, I would say, in this topic. If you have an RTX A4000, even if it has 6,000 CUDA cores, 16 gigabytes of memory, it is not officially supported from the software, and it is not going to work. It's going to give you an immediate error when you try to activate the GPU capabilities of the software. But if you are using something like an Nvidia Quadro P6000, RTX 6000, RTX 5000, 8000, in my case the RTX A5500, the software is like, this is a high-end graphics card with enough amount of memory, with enough amount of CUDA cores, with enough amount of double precision and single precision performance. Now I can use it. And in this case, if you are a huge company that already pays hundreds of thousands of dollars for the software, you will probably pay 3, 4, 5,000 euros for a graphics card that accelerates your workload. So in this case, we can activate like this, in which we say Nvidia is going to be used, it's going to be accelerated, and then at the end we can call the software in order to be computed. And as you see here, for example, now the GPU went from 1.5 gigabytes of memory usage to 6.4 gigabytes of memory usage. The software detects immediately that the graphics card is compatible with the type of analysis, and that you have a graphics card that is also officially supported from the software. And now it's going to tell you, hey, this simulation or this analysis can take advantage of the graphics card. So I'm going to do it. Everything happens automatically in the background, which is pretty cool. Before, back in a few years ago, we used to have to do some stuff in order to make it better or to make it happen. Now it's really the drivers communication. That's the nice thing. The drivers of the Nvidia Quadro graphics card, they communicate immediately with this kind of software, which this is one of the things of this ISB certification that they have. So now it's going to work. And let me tell you again, like, without graphics card and with graphics card, the difference is really huge. It was taking as well like 30 minutes for one solution. With the graphics card, it was taking like 5 minutes or something, like a 6 times 600% acceleration. Insane. And that's one of the things that I really love about workstations, computers, and high-end hardware. The thing that people can do when they have the right tools, like a graphics card, in this case a high-end graphics card, I think is amazing, and I really like that. So if you see here now, the graphics card is being used with 11 gigabytes. 11 gigabytes. Now we are talking about something, no? Which is pretty cool. No? 11 gigabytes. The video encoding Big and OBS Studio is still working. That has no influence in the performance of the GPU. It's a different chip on the graphics card, which is the one that's doing the encoding. The GPU 3D is working 100% of the time, maybe not 100% usage, but is being utilized. Why is not working? Like, because it's not. Why is not the full memory taken advantage of, or the 100% use of the graphics card? Is because depending on the model, in the numerical calculations that you are doing, sometimes you do not need 24 gigabytes of memory RAM. If you have maybe 500,000 elements, there is no need for that much amount of memory. And if you have not that many CPU cores, there is no need to parallelize to something like that, because otherwise you can create bottlenecks. That's what I mean when I told you that there is a trick always in behind these GPU acceleration capabilities. But I want to show you this, and as you see here, for example, this solution uses the GPU acceleration capabilities. And for this software, which is with this software, all the biggest manufacturers in the whole world, even Tesla, the NASA, Chrysler, General Motors, Ford, they use this software. And if you have these kind of devices, you can really take advantage of what they do. Let's continue with some gaming. I mean, I do like play games when I have time, And I will just try to show you a little bit how it performs as well, because there is a lot of you guys that have always this thing of like, Nvidia quadros are not meant for games. That argument was like for 10 years ago or something like that. But nowadays, makes no difference. Just a little bit of performance difference because of the drivers and because of the power consumption, but it's very good.
Several days later.
Previously in Halo Infinite.
Never play actually the multiplayer. I know
Just got word that the Infinity is missing. The ring.
So I think it's just going to
No
be
one knows
great.
where. We built this facility off the grid to train the next generation of Spartans.
It's ready. It's ready.
It's not going to be easy, but I believe in you. They aren't hostiles. They're wolves. Back from the hunt.
This Neuralink is corrupted, ma'am. I'll have to pull the chip.
No! Do that, he dies. And we lose everything he risked his life for.
Eklund, what exactly did Spartan Din put inside his head?
A banished AI.
Who dares to cage the mighty Abaqus? I will crush your bodies and feast on the bone.
We gotta get that thing out of him.
How?
Carefully. And then get it to tell us everything it knows.
This Neuralink is corrupted, ma'am.
Eklund, what exactly did Spartan Din put inside his head?
A banished AI. The first I've ever seen.
Why here?
Because you refuse to see.
There's nothing you can show me that I haven't seen 1,000 times.
Accept the truth. Go on, I dare you.
I told them, go at night. Airborne. Would have been different.
Would it?
Get out. Get out.
But there's so much more to see. I smell fear. How disappointing.
You weren't here! And I'm not gonna let you go any further.
Oh, there's that Spartan spirit. Delicious. But, in the end, pointless.
You don't know anything.
I know you're a fool. Because the truth is this. It always ends the exact same way.
Death for you. In triumph
For me!
So now you are just starting with Halo. It took a while actually to find a match, probably because I'm totally new or something, but let's just start. I never played this. I was reset just because of the intro, and let's take a look how it works. Again, we are testing the Nvidia RTX A5500 from the Ampere generation, just to prove that Quadros are made for game. Yeah. So let's start the game. Let's take a look. I don't know how to even measure the FPS here, but yeah, let's just start. Let's see if it's good. That's me. It's pretty cool. I did nothing absolutely. Nothing. It's just
outkill your opponents and claim victory. They never saw you coming.
Lost the lead.
It plays very good actually. So I think I'm going to play this a little bit more. It's pretty cool actually. Yeah, all in all, the game plays very good actually. I'm just total unexperienced guy. I have no idea. But yeah, let's good actually. So let's go into the next game. Guys, actually that was for me. I'm just going to keep playing this until the match ends. But I mean, all in all, an amazing graphics card for productivity, for all you creators that are going to using this card. Probably I'm going to edit as well my video in this graphics cards just to. I mean, I have no other machine actually. I need to edit this video on this graphics card. It's going to be a 4K video editing with multi-screens. And I think it's going to be very good. So that's all for me, guys, and thank you very much, and see you now. Ja, ich bin am Spielen jetzt, ne?
Die Memo?
Warte. Ich will fertig machen, das Spiel. Ich weiß nicht, ich habe nie gespielt.
Ja, kein Problem, hat das FPS und man kann das wieder abziehen. Eine Rolle wären 2 mal 70 cm und die hat 10 € gekostet.
Und was ist mit dem Preis oder?
Wie weit gesagt hat, wenn die das weiter folieren möchten. Hat sie gefragt, wie viel es natürlich kostet, um es weiter fertig zu machen, weißt du? Ja. Eine Rolle.
Ja, aber gut. Sie hat geantwortet ganz normal, ja.
Ja, aber ich hoffe, das geht wieder von den Fliesen ab und ich krieg die Geld mit Panik.
Active Camo available.
Weiß ich nicht.
Ja.
Ja. Aber sie hatte gefragt wegen den Fliesen, nicht wegen den Möbeln. Bei den Möbeln hatte ich mehr Angst.
Ja, weil das ist die Küche, die immer muss da sein.
Ja, dass die Kohle da nicht abgeht, aber Ja, kein Problem, hat das getestet, man kann 10 Euro, das wären 200 mal 70 Zentimeter. Ich immer direkt ran. Ich hatte extra für 3 Wochen ein Stück Folie in der Dusche hängen und habe dann erst alles geklebt, weißt du?
Ja. 5 Minuten dauern noch.
Ich hatte erst ein Stück geklebt und dann ein Stück geklebt, 3 Wochen, 3 Wochen.
5 minutes remaining.
War einfach und in der Küche hoffe ich auch. An der Stelle habe ich es noch hässlich beklebt gelassen, dann war der schön gemacht. Und dann wieder. Soll ich was sagen oder das abmachen einfach? Das wäre nämlich die einfachste Variante, das abmachen, dann sieht man es nicht.
Victory.
Active camo available.
I'm moving to my new
Don't think twice next time.
Means you have
Ich kämpfe hier, ich sterbe. Ah, wie weg ist. Oh, schon wieder, ich will gerade respawnen.
Not today, friend. What a shot!
Nein, Baby, voll gut, wirklich, alles gut, alles super.
Active camo inbound.
Also fließen, okay, krieg ich sicher ab.
In diesem Fall musste mir eine Küche kaufen.
Active
Für
camo
500
available.
das war. Der wird der schlimmste Fall, dass es nicht gut abkommt.
Spike obtained.
Und
Also
seine
ich
Küche
meinte
kostet
jetzt nur die
500 Euro.
Folie auf den Fliesen.
Ja, aber das für die
Und
Küche.
damals habe ich gefragt, Folie und sie hat gesagt, ja.
Wahrscheinlich weil sie denken, du bleibst da Jahre. Ne? Alles gut.
Das sieht ja auch schöner aus. Bei den Fliesen, die sind halt nicht fertig, deswegen kann ich mir vorstellen, dass es sein wird. Bei den Fliesen kannst du es einfach ab. Ich kann auch sagen, ihr könnt gerne testen und zieht einfach eine Fliese ab.
Ja, Baby, alles gut. Ich bin fertig. Voll cool. And that was a pretty cool game, actually a pretty cool game. I can use since I played Halo Online multiplayer. It was pretty cool. Oh, ich habe ein paar Punktchen gemacht. Ah, voll cool. So guys, now we're going to continue with Horizon Zero Dawn. It's a pretty cool game, pretty cool game, and I think it has a lot of really nice colors. The scenes are also pretty cool, and I think just to show you how these graphics can do as well play games, I think this is a very cool game. I hope you can see as well at least a little bit of the quality that I'm seeing here now. It is 4K native with the ultimate quality settings, and everything is maxed out, and it just looks very cool. Let's try if we can do something here, and just to show you how smooth it is, and of course the quality of everything.
Being able to override you would help.
We can make these guys float. It looks pretty cool actually, pretty cool, and everything's very smooth. For sure, we're playing at more than 60 frames per second. But I don't care about the FPS, so I never mess with it. But I think it looks fantastic, really great. Let's run. I don't want to play there. Let's go to a hacker place now. Fantastic. Now it's everything really hard. Let's explode one of these. Now we're playing the Rise of the Tomb Raider, pretty cool game as well, and this is everything as well, native 4K, everything maxed out, ray tracing on, and yeah, let's just play. I just finished the Pride of the Eagle, I think is the name, and I still haven't finished this game actually. I'm pretty excited if maybe one day I can finish it. And the game is pretty smooth, it's running super smooth. It's a little bit dark here, but let's see if we can make it to a better place. Yeah, for example this, and the quality is just insane, brutal quality. I hope you can see everything here, the details.
Jonah?
Yeah, I mean these graphics cards are nowadays also meant for gaming, and there is no difference in between the RTX GeForce and this ones. Really no difference. A little bit of performance penalty because of the drivers and because of the power consumptions. But as I just mentioned, other than that, these graphics cards are so good as gaming as the counterparts. Really good. Just that one. The one thing that I really think is very important to take care of is the power consumption. You can overclock the GeForces or the gaming graphic cards, or there are 4090s that they take up to 400 watts of energy. These Quadro cards, they are not going to push that hard. But other than that, it's always the same. They are very good. Look at the details, look at the lights, the ray tracing. Everything looks pretty good for Tomb Raider as well. That's a pretty cool thing to do actually in this game. That's what I like about Tomb Raider. It has pretty nice puzzles if you like that kind of games, and it has pretty cool scenes, just like a solo player, and I personally do like that a lot.
To conclude the video, I will take a little bit of a break in the direction of how do you really justify having one of these, or how do you really justify requiring one of these graphics cards. If we just mention that the price of the RTX 3080 Ti, it is 3 times or maybe less than 3 times lower than this one, what really features, or how do you justify asking for this, or giving to yourself this? In my case, for example, why do I need this? No? As we just saw, there is software like Solidworks that benefits insanely with the Nvidia RTX professional drivers. Believe me, as I just mentioned in all my graphics cards reviews before, the drivers optimizations for software like Solidworks, like Catia, like Siemens Unigraphics, if you are a design engineer, if you are a product developer, it's really not comparable with the gaming graphics cards. So for those applications in which the data sets are very large, because as we just mentioned before, the RTX 4000 series or the Quadro 4000 series, like the RTX 4000, the RTX A4000, the Quadro P4000, the Quadro Maxwell 4000s, those can really help you for almost all the design, the construction, the 3D modeling application that you are going to use, even in a professional environment. Like if you are using Solidworks, Unigraphics, again, Catia, if you are using PTC Creo, if you are using Inventor from Autodesk, most of the 4000 series are going to make the job brutal, like really insane. They are not going to fail, they have enough performance, they have enough memory, and they are really just going to push through your HUD, or they are just going to push through your workflow through the day, no problem. So when do you require this 5000 series? When do you require this dual slot Nvidia Quadro graphics cards? To be honest, just when the applications or programs or numerical simulations that you are working on, they require the extra amount of memory. They could benefit with the extra amount of CUDA cores that these graphics cards offer, because there is even today only these high-end or ultra high-end professional graphics cards offer those kind of features. If you really could benefit like that, like for example in my case, as we just saw before, when you are using finite element software and you are really working with huge models that has a huge amount of data sets, like millions of elements in my case, those elements need to be allocated in some place in order to all the calculations to be made for those elements. And if you have, for example, an Nvidia RTX A4000, maybe for the design part, for the preview, for the post-processing, is going to work perfect, like really perfect. Even it is going to be overkill. But if you are trying to compute or to offload these numerical simulations into the graphics cards in order to accelerate your computational time, those graphics cards are not going to work anymore. They are just not going to make the job. They are just even probably make worse the computational time. And that's when, for example, for mechanical engineers, a graphics card like this is going to make magic. It's going to help you a lot, and it's going to really give you an insane amount of benefits in comparisons the smaller graphics cards like the 4000 series. Or for example, if you are working with deep learning algorithms and you have like a neural network in order to perform a real-time object recognition program, and you are using maybe a webcam or a high-end camera in order to capture continuously capture images for your program, and just not even the training, just maybe the processing on real time of those images. If you have not enough power, you are not really making really a benefit. And for those applications of machine learning, for example, this kind of graphics card is going to help you a lot as well. Price, that is actually the elephant in the room for this graphics card. The price, I will just tell you, it is not justifiable. There is no reason for Nvidia to put such a high price in such a graphics card. I mean, the RTX 3080 Ti, which is even better than this, in performance, like raw performance, it is more than 3 times less the price than this one. That is actually the problem of the high-end Nvidia Quadro Graphics Cards, that you probably, there is, maybe, I will just exaggerate a little bit, but it's almost true. There is like 1 million videos of the Nvidia RTX 4000. And there is like 10 videos with the ultra high-end graphics card of Nvidia Quadro. Because there is just really not reason for normal people, like for consumer people like you that are watching this, you know, to have this. If you work for companies, if you are a researcher that is really into deep learning, if you are a company that it is building his cluster in order to perform now machine learning operation or really heavy duty artificial intelligence operations, of course then you can really benefit of this. And the price of 3,000, 5,000 euros for an accelerator, it is nothing in comparison the H100 or the A100 that they are priced like at 10, 12,000 euros. If you are building something like that for you in your home as a home lab with 8 of these ones, maybe it is justifiable the price. But otherwise, I would recommend to stay away from this as much as you can, only when you need them. In my case, they accelerate insane. Like really from 2 hours computational time to 6 minutes. Can you believe that? I mean, if you are an engineer and you are wasting 2 hours of your time, of your machine time, just trying to compute one solution with the CPU, and even if you have 18 cores, 36 threads like my machines running at more than 4 gigahertz, 2 hours computational time, 2 hours, 120 minutes. And these guys can do it in 6 minutes using this one. Can you imagine? You have like an increased performance of 20 times performance increase. And for those kind of applications, for me as a mechanical engineer, for the visualization of really heavy data sets in 3D models, because I really push very, very hard my software, it helps a lot. If you are a gamer, or if you are an engineer like me and you are also a little bit of a gamer or something, if you really don't need this, stay away from this. This is very expensive. It is very expensive. It is just very expensive. Even the increased amount of memory in comparison of the 3080 and 3080 Ti does not really justify that price. Because I mean, if you want another kind of graphics cards that offers a lot of memory, you can get an Nvidia Quadro P6000, for example, an Nvidia Quadro P6000 from the Pascal generation. I had it as well before. I actually reviewed as well in my YouTube channel. It offers as well 24 gigabytes of memory. And if you need the memory only like maybe like for rendering or like, I don't know, 3D modeling, pure 3D modeling, get one of those. It is going to cost like as well 800 euros or something like that, and it's going to push incredible your workflow. But in conclusion, these graphics cards sadly are still overpriced from Nvidia. Really, really overpriced. And the features that, for example, Solidworks or Catia or Siemens Unigraphics benefit from them, or software like Abaqus from Dassault Systems, or software like Ansys, like MATLAB, probably only companies or huge companies, or maybe some now, maybe few startups have access to those programs. And to be honest, only those kind of companies can allow themselves to pay the price for this kind of machine, for this kind of devices. And that's a little bit sad. And yeah, I mean, I'm very, very excited because it offers a great amount of performance. Like really, I probably is the best graphics card that I had in my entire life. For gaming, 4K, 120 Hz, HDR, G-Sync, everything that you want, it is capable of it. In ultra settings for each game that I'm playing, it is going to make it, but at what cost? Yeah, that is the thing that I don't like. But for my workflow, for my tasks that I do, it helps a lot. And if it really helps you for your workflow, if you really benefit from it, then it makes a lot of sense. And that is actually the purpose of always Nvidia Quadro lines graphics cards or professional graphics cards. If you are a professional that can benefit from the features that they offer, they are going to make an amount they are going to make a great difference in your workflow. For me, that is the case. That's why I have it, and it is actually a pretty cool card. It's actually a pretty cool card as well. I'm very excited of using it. I know that I have no limits in my machine. I know that with my machine I can do everything. I can just test simulation, I can help someone in order to accelerate their simulations, I can try new things, I can try the new Nvidia Omniverse platform of artificial intelligence accelerated complete platform of simulation, physics simulations, rendering, lighting simulations, mechanical simulations, and all those things. I know that I am now enabled to do that. It is not something like your graphics card doesn't tell you what to do. It is everything here, of course, but at least you know that the tools that you are using, remember I always say in every of my video, these here are tools. At least the tools that you are using are not the limit. At least the tools that you are using are not making a bottleneck of what you can do, of what your creativity can do. So I'm very excited, as I just mentioned. Very nice graphics card, the best graphics card that I hold in my hands in my whole life, and I had a lot, and I just really, I'm going to keep using it. I'm going to keep gaming on it. I'm going to keep doing all the tests in Solidworks, in Catia, for finite element simulations that I can do in order to show you and share with you what are the real benefits of this kind of graphics card. But for now, that's all for today. I think with all the demos that we made in my computer, we had enough. It is a long video, and I just want to it's a long video, and I just wanted to thank you for coming back to my channel, taking a look to these kind of things that maybe not a lot of you guys are interested. So thank you guys very much for watching, for coming back. I'm really doing my best in order to keep pushing this topic of IT for engineers, IT for researchers. I will do my best to keep pushing as much as I can, as much as time I can make. But for now, that's all. Thank you again for watching, and see you until the next time.